October 11th, 2012. First, we will do the second test. It'll cover chapters 3 and 4. We'll do an in-class activity following a test on pharmacy calculations. Quickly, we will go through a basic math review of numbers, fractions, decimals, significant figures, measurements, equations, and variables. Then we'll do percent and solutions, allegations, powder volumes, children's doses, and finally business calculations. Homework is to review Chapter 6 and Workbook 58 through 67 for the October 25th quiz. Continue Chapter 18. It is a lot of material and you'll be more successful if you break it up and continue to work on your research paper. The deadline is in 2 weeks from today on 10/25. I will need either a hard copy or you can email me a copy of your research paper. The learning targets for today's class are: I can define numerator, denominator, fraction, and decimal, solve simple mathematical problems using fractions, decimals, percentages, ratios, and proportions, convert between the metric system and other systems, solve a variety of pharmacy dispensing math problems, and finally perform basic calculations associated with the business aspect of pharmacy. Numbers include Roman numerals, fractions and decimals with the numerator and denominator, numerator on the top, denominator on the bottom. 1/2 is equal to 1 divided by 2, which is the same as 0.5. I expect you to know how to add, subtract, divide, and multiply with fractions. Be able to convert between fractions and decimals. Significant figures. There are 4 rules. Digits other than 0 are always significant. Final zeros after a decimal point are always significant. Zeros between other significant figures are always significant. And finally, zeros used only to space the decimal are never significant. Measurements include metric system and other measurements. Drams and minims are rarely used today. Common conversions. 1 teaspoonful is the same as 5 milliliters, is the same as 5 cc's. 1 tablespoon is the same as 3 teaspoonfuls, which is the same as 15 milliliters. You should be able to convert between Celsius and Fahrenheit. 1 pint is approximately 473 milliliters. 1 fluid ounce is approximately 30 milliliters. 1 kilogram is approximately equal to 2.2 pounds. And 1 pound is approximately equal to 454 grams. Equations and variables. Equations are mathematical statements in which 2 terms are equal. The unknown number is the variable and is usually represented as x. Ratios and proportions. A ratio states the relationship between 2 quantities. A proportion are 2 equal ratios. Percents and solutions. Percents are used to indicate the amount or concentration of something in solution. It can be weight to volume or grams per 100 milliliters, volume to volume or milliliters in 100 milliliters. Percents and solutions. An example would be the doctor wanting a 35% solution of dextrose in 1 liter, which is the same as 1,000 milliliters. You have 50% solution of dextrose in 1 liters. How will you make this solution? You start out by setting up the formula, which is x mLs are equal to 35% times 1,000 milliliters divided by 50%. The percentages cancel out, and you'll add 700 milliliters of 350 grams of dextrose. Step 3, when you finish, total volume is 1,000 milliliters minus 700 milliliters. You will add 300 milliliters of sterile water, which will now give you 35% solution of dextrose in 1 liter. Milliequivalents. Electrolyte solutions are often used in hospitals. Milliequivalent is a specific measurement that cannot be converted into the metric system. It's based on each electrolyte's atomic weight and known electron properties, which are known as valences. Common electrolytes are listed, as well as common saline solutions. Total parenteral nutrition is a way of supplying all the nutritional needs of a body by bypassing the digestive system and dumping nutrients directly into a vein. Purpose is to be used when individuals cannot or should not be getting their nutrition through eating. An example of this, a TPN order calls for the amounts on the left, including additives to be made from the items on the right. The total volume would be 1,000 milliliters. Note that sometimes the 0.5 is rounded down, more than 0.5, or 0.5 is rounded up. Some drugs may be rounded, others will not be rounded. Your total parenteral nutrition in this case is you will be adding 500 milliliters of aminosin, 8.5%. You'll be adding 375 milliliters of dextrose, 70%. You will be adding 10 milliliters of potassium chloride, 5.45 milliliters of sodium chloride, 10 milliliters of multivitamin. Sterile water will be added to this as well. You go 1,000 milliliters, which is what's needed for the total parenteral nutritional bag, subtracting the 500 milliliters and the 375 milliliters and the 10 milliliters and the 5.45 milliliters and the 10 milliliters, you will be adding 117.55 milliliters of sterile water. Second example, which you will be making for a 250 milliliter bag, is given here. Total amounts of each product is given here, and here, and here. Now you subtract the 147 milliliters and the 37.5 milliliters and the 2 milliliters and the 0.45 milliliters and the 5 milliliters from the 250 milliliters total, which gives you 58 milliliters of sterile water. Alligation is a way of solving problems when mixing preparations of two strengths of the same substance. It's a grid of 3 by 3 and is set up as shown on the right. An example of alligation is you are combining 1% hydrocortisone cream with 5% hydrocortisone cream to prepare 30 grams of 2.5% hydrocortisone cream. Lower strength is upper right-hand or left-hand corner. Higher strength is in the lower left-hand corner. The desired product is in the center. Calculating the number of parts needed is in the upper right-hand corner for the lower strength, and the higher strength is the lower right-hand corner. Plugging numbers in, that gives you the answer. Powder volume. Some medications are dispensed in a liquid form, but manufacturers and provided to the pharmacy as powders. The powder is then mixed with sterile water to make the correct amount and dose of the medication. The general formula is final volume is equal to diluent plus the powder volume. Here's an example of how you would do this. Children's doses. Clark's rule is the weight of the child divided by 150 pounds times the adult dose, and the body surface area formula, which is the child's body surface area times adult dose divided by the average adult body surface area. An example of calculating a child's dose based on how much you give per milligram, how many milligrams of the antibiotic IV are given per kilogram of the baby. First, you need to convert from pounds to kilograms, and then you solve for the dose. Business calculations. Usual and customary prices is the lowest price charged if a patient pays cash on the day the prescription is picked up. Some pharmacies will sell certain medications at a lower than acquisition cost. Therefore, usual and customary price may be less than the average wholesale price or the acquisition cost. Also, third-party plans may also pay less to cut costs. Finally, discounts are sometimes given to certain patients, such as the elderly. Business calculations The two formulas that I expect you to, or two ideas I expect you to know, are the gross profit, which is the selling price minus the acquisition price, and net profit, which is the selling price minus the acquisition cost minus the dispensing fee, or the gross profit minus the dispensing fee. This week's note card, in addition to what you learned, what I would like you to do differently is I have a couple of requests given on the quiz earlier, so choose one of the following. Leave it as it is, give the quiz before notes, give the quiz before the in-class activity. Chapter 6 review and workbook should be done for next week. For the October 25th quiz, you should continue reading Chapter 18. It is a lot of material, and you'll be more successful if you break it up. And you should continue working on your research paper. Deadline is 2 weeks from today on 10/25. I'll need either a hard copy or you can email me a copy of your research paper.